Hello, and welcome to another episode of the Data Science Leaders Podcast. I am your host, Dave Cole, and today's guest is Kli Pappas. How are you doing today, Kli?
Great. How you doing, Dave?
Great. So Kli, your background, you're an Associate Director of Global Analytics at Colgate-Palmolive. You also have a PhD in chemistry from Princeton. So I'll dive quickly into how you segued your career from chemistry into being head of an analytics team. But before we do that, I always like to sort of tease the agenda at the outset here. Today, we're going to be talking a little bit about how to balance your team between sort of the traditional sort of stats background that we see amongst analytic teams, and sort of that comp sci sort of software engineer background. And then we'll go to our meaty topic, a unique one, which is patenting your work and why, as a data science leader, you might want to consider filing for a patent. So, Kli, how are you doing today?
Doing great, Dave. Happy to be here. Thanks for the invitation.
Awesome. So let's. So how did you go from getting a PhD in chemistry, not for the faint of heart, and then moving more into an analytics world here?
Yeah, it's funny. I always had an interest in computer science. I started off as a computer science major in college and learned some Visual Basic. During my PhD, I did, no one writes Visual Basic
Exactly.
anymore.
But that doesn't apply too much these days. Yeah.
For good reasons, I'm sure. And so during my PhD time, there was a lot of work going on in chemistry as a whole, trying to figure out how to use machine learning, specifically neural networks, to learn chemical reactions. If you look at chemistry, it's still very much done the same way it's been done for 200 years, which is you run an experiment, see what the outcome is, then you change a variable and you run another experiment, and then you iterate as you go. And so there's a lot of work that's been going on to try to collect the corpus of experiments that have been done and do some modeling work to be able to predict outcomes, to design catalysts that make better drug molecules. So that sort of piqued my interest a little bit. And when I started working at Colgate, this was just about the time that data science was really coming into itself as a field, and really saw an opportunity there to do something very similar on the Colgate side, which is, figure out how to try to take the massive amount of product development work that goes on, which most people don't realize. You see a product on the shelf. What's behind that product is usually thousands of experimental products that a person actually made in a lab at the company and iterated on. So there's a tremendous amount of information there, and trying to figure out how to use that data to make it so scientists can predict the properties of new products before they sort of go into the lab and experiment on it. And then that kicked the whole thing off.
Well, I mean, the way you describe chemistry as being sort of a process by which you experiment, change a variable, and then sort of wait for the chemical reaction or what have you. I mean, in a way, that's a sort of a simple explanation for what we do in the data science world at scale. So, like at a very high level, there's a high amount of parallels there, and it sounds like that's exactly kind of what you've done is in that it was what you're doing today within your team, is to try to make I imagine those real world experiments sort of kept to a minimum, and working on the ones that have the highest probability of success. Does that sound about right to you?
Yeah, and I think there's an interesting transition there to the first topic that we wanted to talk through, which is data science is a science. So, sometimes the term gets used as data science, right? Yeah. And I think what we forget, and you see this a lot with people who come into data science from computer science field, or people who come over from IT, which is data science should be hypothesis-driven research, right? It's not about the data and the manipulation. It's about having a hypothesis about what the real world is like, and then doing experiments on your data to confirm or reject that hypothesis. Mm-hmm. And that's a concept that comes natural to some people, comes natural to people who are from the sciences field, and is a conceptual framework that sometimes you see people who are coming over from IT or from the computer sciences in general miss. But that's why it's a natural fit, I think. And you see a lot of people with backgrounds in physics, chemistry, biology moving over to data science because they have that notion of it, that really this is a science and it's about hypothesis-driven research, falsifiable hypothesis-driven research, which is what science is.
Right. And to do the hypothesis driven research, you also and where you're using data to sort of validate your hypothesis, having a strong statistical background makes a lot of sense. So what I've always
Yep.
found to be sort of a commonality amongst sort of PhD candidates in the hard sciences is they also tend to have a very strong stats background. Is that kind of in your experience as well?
Yeah, agreed. And I think, some of the technical details are sometimes missing, but the conceptual framework around, why, where, and how you would apply statistics, and the idea of variability and the idea of data providence is baked into, people with a background in hard science. One of the things that you get from coming out of the hard sciences is you generate data when you're in the hard sciences and then you analyze it, right?
Right.
If you just come into data science, from an outside field, data is a received truth, right? It's like the
Yeah.
golden tablets come down, and that the data is what it is. And I think there's sometimes a miss from data scientists is thinking about what is the provenance of the data? What did it actually look like at the time people were generating it, whether
Hmm.
generating it means running an experiment or generating it means I clicked a button on a website. And that insight into what the provenance of the data is like critically important to
Yeah.
formulating a hypothesis about it. And people with a background in the sciences know that because they do experiments. And that's also why, if you look at the way data science is typically described. You have this Venn diagram of three things. You have computer science and statistics
Hmm.
and domain knowledge. To me, the domain knowledge part of it is really getting at how well do you understand where the data came from and how it was generated, because that's really going to inform your analysis strategy.
Right. If you understand that, I mean, also, I think, when I think of sort of the domain knowledge, I also think you truly understand the business problem. So if you truly understand the
Right.
business problem, you also truly understand like how the data came to be, and what the various fields actually mean in the real world, and so on. So we talked a bit about, folks in the hard sciences have PhDs, that tend to have a strong statistical background. I imagine you also look to hire people who actually have a PhD in stats and things of that nature. But then you're also looking at, you also balance out your team with folks who have more of your typical sort of computer science background when it comes to as a software engineer type background. So how do you see those two roles evolving in your team, the two backgrounds evolving on your team?
Yeah, I think the best quote that I've seen about this regarding statistics and computer science and data science is that you must have an appreciation of both and a mastery of one, right? And as a hiring manager, it is always the case that there is never a person that is that perfect Venn diagram, right? You
Yeah.
have people who, by background or by disposition, sit more on the stats side, and people who sit more on the computer science side. Sometimes you can see that immediately when you're interviewing people or looking at their work. It's like, is this person using R or are they using Python? Are they
Yeah.
writing notebooks or are they, leaning more on the, writing .py files and, structured code? So
Right.
sometimes it comes out directly. In terms of balancing those two roles, there's really a couple things that I think about there. One is the maturity of the analytics organization itself. So if you think about an organization at a very immature state on the analytics continuum, a lot of the work that's going to drive a ton of value is not deep statistical work. It's relatively simple things, arithmetic stuff, or slicing and dicing of data and scaling it.
Hmm.
And if your organization is early on the analytics curve, that will drive a ton of value, and you probably don't have a lot of people, so you need people who can have a big impact and scale what they're doing. Further down on the continuum, when that low-hanging fruit has been taken, that's when the meteor problems come up. where you can maybe now start to support ad hoc projects, and you need some people with more of a statistical background to dig in. The second thing I think about is the types of problems that you're working on. So, back to what we talked about before with, is data received truth, or is data something that is generated? If you're looking at an organization that has a research and development org within it, so pharma or consumer packaged goods, things like that, a lot of the data is generated internally, and oftentimes the question comes up. You try to build a model or something, and it's not all the way there. And so you have people who will ask you, well, what data should I be generating to make the model better, right? And that is not a question that data scientists who come from the CS side are used to handling, right?
Yeah, yeah.
Because data is this big thing that's out there, and you get it, and it is what it is. It is a question that statisticians are very well versed at answering. So, there's a whole subfield of statistics called design of experiments, which is all about how to design well-balanced experiments. And so if those types of questions apply to what you do, which is you have people in your organization, whether it's running a clinical study or doing a consumer test, who are going to be generating data, then people with a statistics background, are really best situated and have more firm training in how to make sure that the data that gets generated is well balanced. So on my team, we do a decent amount of work in that area because we work with our global technology team, and we support the clinical function and consumer testing. And in those cases, data provenance is very important, and scientists can go run the experiments that we ask them to run to build out a more robust data set. And my statistics people are great with doing that. And I guess, I should say there's like kind of a third and fourth category of people. So we talked about, okay, you have people who studied stats and then they learned to code. Those are your statistical data scientists, right? You have people who studied CS and they learned statistics, or they learned data science. They did a master's degree boot camp, right? And then those are your CS data scientists. There's a third group of people who I call passionate converts, and that's the group that I would put myself in, which is they studied almost anything, right?
Yeah,
Some of
yeah.
them have an advanced degree in the hard sciences. Some people come from engineering, totally unrelated field, and they just, by disposition, they know how to code, they know how to ask questions, they did a master's degree, or sometimes all they did was a boot camp, and a lot of those people are very good, if you get them in and you get them the right training, because they have the passion to ask questions. And, I give a lot of credit to people who change careers and change fields. Like, if you've been in a field for 5 to 10 years and you leave that field entirely and do a data science boot camp or get a master's degree to switch fields, like, you are inherently, to me, a pretty special person, because not a lot of people do that, right? And so I have a lot of love for people in that passionate converts area, because generally they're curious thinkers. They know how to self-learn, which in data science, it's like 90% just looking stuff up and reading and teaching yourself how to do things. So that's sort of the third bucket. There's a fourth bucket that I don't have a lot of experience with, that's new, which is people who just studied data. They have a bachelor's degree in data science, because everyone knows data science is super hot now, sexiest job of the decade or whatever. So a lot of universities now are having data science undergraduate programs. But that's pretty nascent. So
Yeah.
there's lots of questions there around well, do they actually understand a domain, or is their domain just slicing and dicing of data? So that's like a new area.
Yeah, I was going to say, like, if in that fourth bucket, having sort of a bachelor's in data science, like you're probably in your mid to early 20s. You're probably relatively new to this career, and it is interesting, right? Like will you compare somebody like that 10 years from now to the passionate convert who didn't start in any sort of formal sort of data science training, and probably had a more well-rounded background and sort of like purposefully went into data science and had sort of a passion for it. It'll be interesting to sort of compare and contrast a few years from now to see how they will differ. I don't know. My personal take is that I think the the passionate convert is going to be extremely deep on sort of the domain expertise side, but might
Yeah.
not have like the formal stats or programming experience. But I mean, to your point, so much of that can be learned, like I think, in some way, on the job or through more formal sort of online training as well. It's certainly I would put myself in that bucket for the record. And
Yeah.
I'm glad to hear that you're in that bucket too. Well, cool. Well, I want to. That was a fascinating conversation. I want to switch gears abruptly and talk a little bit about just kind of your the patent that you filed. Maybe just briefly describe what it is, and then we can talk a little bit about the process and really I think what everyone is probably interested in, including myself, is the why, right?
Yep. Yeah, so initial disclaimer here. So I am not an attorney for PhD in chemistry, and I definitely don't speak on behalf of the attorneys at my company, but
Right.
I have been through this. I have like more than 10 granted patents, so I've been through the patent process a lot of times, both in the chemistry side and in product development, and now some more recent patents that relate to data science. So I've spent a lot of time thinking about what it means to patent work, and on the sort of leadership side, working with ideas and thinking about ideas in a way to get ownership over them. And also, not just ownership. I guess the other thing to start with here is sort of the elephant in the room when it comes to patenting as it relates to data science is there's, I think, this notion that the patent system itself is like antithetical to the ethos of open source data science. It's like,
Yeah.
how could you, you're
You're a traitor.
yeah, right. You're taking these ideas, and that's not what data science
Yeah.
that's not what data science is. And I don't think that that's the case. I'll try to talk you through why I think that that's not the case. So by way of background, the thing that you were referencing before. So myself and my team recently filed a patent on a process it's similar to the thing that I was describing to you before, which is taking the massive amount of historical product formulation data that Colgate has. So I'm talking about, formulations for hundreds of thousands of products,
Hmm.
most of, 1% of which go to market, right? So all of the ingredients that go into it and all of the properties about the product, what it felt like when we ran a consumer test, what the clinical efficacy was, what was the pH, was the active ingredient stable, did the flavor go bad, how thick was it, how gritty was it, if it's a toothpaste, was the color stable, if it's like a body wash or a hand soap, right? So taking all of that information and using it to build an algorithm that can take just digitally a list of ingredients and then predict what the properties of that product would be, both consumer attributes, clinical attributes, and physical properties of it. But you can't patent an algorithm. I'll
Hmm.
talk about that.
Hmm.
So really, it's about the process. So taking that and reducing it to practice, where you make a product and then you measure the product yourself, and then use the outcome of that to feed back into the algorithm and into the process. And we actually won the Edison Patent Award, which is from the Patent Council of New Jersey. They give out awards, and so we won an award in a segment there for the work, because it's really sort of the first patent of its kind in the CPG industry of using models in this way to come up with an overall process. So taking a step back, just where did this come from, and how did we think about it? When you look at the intellectual property related to the work that data scientists do, there's really three ways that you can go if your data science team is working on something. You have a copyright, so you can copyright your code, right? And the important thing and most code that's out there, like on GitHub, is copyrighted, right? So the important distinction for copyright is copyright protects the expression and not the idea itself. So the expression would be, the text of the code, but not the idea behind what it does, right? So like, NumPy or SciPy, for example, do numerical transformations. The copyrights on those are not, copywriting the idea of calculating a distance matrix. It's copywriting the actual code that does it. So that's one avenue you can go down. The other avenue is trade secret. Okay, so that's, I think by far the majority of code that gets written in data science is trade secret. Most companies with data scientists working on stuff are not using, putting all of their work on GitHub publicly.
Right.
So that's sort of strike number one against the ethos that data science is meant to be open.
Yeah.
How much code do you
Look in the
think
mirror.
that's
Yeah.
written by data scientists actually goes into open source?
Right.
So trade secret is a route that you can go down. There is open source. So open source is another avenue you can go down. Open source is interesting. So, there's three things that need to be the case for something to be considered open source. It has to be publicly accessible. People have to be able to use it without royalties, and derivatives. You have to be able to make derivatives of it. But even open source, the foundation of modern data science, those open source libraries that everyone uses in Python, they are all copyrighted. So they all have copyrights. They have different licenses associated with them that say how you can and can't use it. But if you take something like NumPy is a copyrighted open source. And if you make derivations of NumPy, for example, your copyright has to be at least as open as their copyright. It's called a copyleft license, right? So even the open source community, all of that stuff is protected by copyright with rules around how you can use it. And there's stuff that you can read about the different types of copyrights. Many people are not aware of that in data science, and I'd say if you're a data science leader, you should make yourself just generally aware of the packages that the people on your team are using, and go to GitHub and check the copyright licenses to make sure that you can use them in the way that you're using them. Otherwise, you can sort of get yourself into trouble if you don't do that. The big things are usually fine, but it's worth looking at. So then that brings us to the last thing, which is patenting, right? And so what does it mean, and when would you patent data science work? So why do patents have sort of a bad name? There's patent trolls and lots of negative connotation around what patents are and what they do. So patents have been around for a long time. The patent laws in our Constitution that Congress can give out patents to people. And what a patent really is, and sort of how this ties into what the ethos of data science is a patent is not, does not give you ownership for an idea. A patent is an exchange. It's an agreement between you and the government that you will disclose your idea in full detail. You will publicly disclose it. And in exchange for publicly disclosing your idea, you get limited exclusivity to use it. Right? So a patent usually lasts 20 years. So a patent is a mechanism for the government to make sure that ideas get put out there in the world. So to incentivize people to put ideas out there in the world, and the way they incentivize you to do that is they give you limited exclusivity for 20 years over that idea, and then it becomes totally open, public domain entirely for anyone to use that idea. So kind of the considerations around filing a patent in this space. So patenting in this space is a little bit complicated because you can't patent math, right? You cannot file a patent on an algorithm, right? And an algorithm is a fact. And there's sort of the notorious thing here in the patent law is called like 101, which means is the subject matter patentable? And you cannot patent like a math equation, right? So usually, to patent something, so here's an example. You can't patent a neural network, right? But you can, and people have patented a neural network that creates music, because you're taking the algorithm and reducing it to practice and making something useful from it. And so there's a hurdle that you have to cross when you're patenting something, which is the non-obviousness hurdle. So it needs to not be obvious. The thing that you're patenting can't be obvious to someone in the art. And so, the patent examiner on that one deemed that it was not obvious that you could take an algorithm and, make Mozart, for example.
Yeah.
And there's a patent out there in the world. You can look it up where someone patented that. So the consideration for patenting is really, is there an idea behind your algorithm, and are you reducing it to practice in a practical way? Like, are you making something from it? That's usually the step that needs to be there. You need to have the algorithm and you're producing a tangible output from it. And really what you're patenting in that case is not the algorithm, it's the process. It's the process of using the algorithm to come up with some meaningful outcome. And so what that means, so take my case, for example, right? We have an algorithm that predicts the properties of products, and the
Hmm.
process is like producing the product from it. Um, but someone could use the algorithm, that's fine, right? We haven't patented the algorithm itself, but we're patenting the useful application of that to make a product. So that's always the thing that you need to make sure that that's there if you're thinking about patenting something, is there has to be some utility or reduction to practice, and some non-obvious part of it. So what it looks like in practice to do this is, you would typically work with, a patent attorney and sort of put together a draft of what the idea is, and, try to, frame it in such a way that they understand what the process is, like what is the idea behind it. And then from there, it's really the patent attorney's job to try to make sure that it checks the boxes for what is a patentable invention. Then that gets filed. The amount of time that it takes is extremely variable. So
Right.
typically it takes years from filing to granting. So I've seen it take more than 5 years. Um, you can fast track patents. So the U.S. Patent Office will let you fast track patents. You pay extra money, and then it gets more immediate consideration. So that's another route to go down. And in that case, I think it's like less than a year. They like guarantee you that it'll be examined. Um, so that's sort of what it looks like in practice to take your work and patent it. Um, so
So
yeah, yeah, go on.
then the next, I mean, I think the question that I have, I mean, this has been fascinating in terms of understanding, how the whole patent process works as it applies to data science, and what are some general rubrics, is it non-obvious, which then lends itself to being patentable. But I think the burning question here for me is why? Like, why would you go about patenting a process that specifically the process that you designed? I imagine it's for sort of competitive, defensible reasons.
Yeah, it's a good question. So, the most companies, and I think most teams, would lean towards trade secret for
Right.
for things, right? Because patent, you're fully disclosing what you're doing. And patents are enforceable only when someone sues to enforce them. So it's not like a patent stops people, like the patent doesn't fly in the window and like
Yeah.
break your keyboard when you're doing something. You have to find out that someone is infringing on it,
Right.
and then decide to sue them for it, and then have all the litigation around it, right? So
Right.
so there's lots of reasons not to patent things, because how are you going to enforce it, right? Um, and would you want to enforce it, and would you want to pay the money that it would take to do it? So why would you do it? So there's a couple considerations that come in. One is being able to talk about your work at any level of detail. So since you're patenting an idea, so say you copyright a piece of code, that's great. You can, go out, you can talk about the idea behind your code, because maybe the idea is not patented, but no one can steal it from you based on your talk, because they don't know actually what you did, right? Your code is a trade secret, and you have it copyrighted and keep it within your company. So great, you go out and talk about it. Um, when your invention, when the code behind your invention is not special, right? When anyone could do it, when
Right.
you could go out to a conference and talk about the idea, and then anyone else can write their own code and do it, then that's problematic, because in that case, it's not the code is not what's special, it's the idea that's what's special. So that's sort of reason number one why you might want a patent, which is you want yourself or your team to be able and to go out into the world and talk at conferences, or talk to investors or shareholders, whoever it might be, about this great idea that you guys have, that you're using to make money for your business, or better connect with your consumers or people around the world. And that idea itself, you don't want anyone to take that idea, but you want to be able to talk about it.
Right.
So that's sort of one side. The converse side to that is purely defensive, which is maybe you don't want to patent the idea because you don't want to disclose it, but you're kind of worried that someone else might come along if you keep it as a trade secret. This is a general issue with trade secrets, right? You could keep a trade secret. So Coca-Cola could keep their, the heart of their Coca-Cola trade secret. But then if you discover what it is, you can patent it, and then you have the patent for that.
Right,
And
right.
so you could be doing something for 20 years and keeping it as a trade secret. Someone else patents that, and then you are now excluded from doing it. So the patent law recently changed in the US on this. So it used to be the first person to invent something. And you had, wars that would go on over patents where someone would grab their lab notebook and bring it and say, as you can see, in my lab notebook, I did this experiment in 1982. And
Right.
then it's like, okay, well, actually, you don't have the patent. This guy did in 1982. So the US patent system switched over to what's called first to file, which means it does
Hmm.
not matter anymore who was the first person to make the discovery or to come up with the idea. The only thing that matters is who was the first person to file the patent. So they did that because of all the complexities that were associated with who was the first person to invent. You have, cases going to court and, scribbled stuff on pieces of paper. Did you discover the idea? So now it's first to file, which means you have an idea, you keep it a trade secret. I have the idea. Maybe I talk to you somewhere, whatever it is. And then I file a patent on it. Now it's my idea. I own it. You can't do it anymore. So
Right.
so there's a defensive side to it, which is if you think, you could run into that situation, that would be kind of reason number two to consider patenting. If it seems reasonable to you that, this is a really important idea, the source code behind it is generic, like there's 100 different ways you could do it if you had someone who's like skilled in the field, and you don't want to be blocked from using your idea in the future, then you should patent for two reasons. So say you file the patent gets rejected.
Hmm.
That still protects you because the act of filing the patent puts that idea into the public domain. So no one else can patent that idea
Right. You're first to
anymore.
file. You're first to file the rejected patent. Yeah.
Well, yeah, and you don't have the idea, but now it's public domain, right?
Right.
And so it's not an original idea for anyone else. So if someone else comes along, they can't patent the idea. So just filing the application puts it in the public domain, protects you from someone else taking it. And if the patent gets granted, now you have exclusivity. Patent doesn't get granted, you're at least not blocked from using the idea. So that's
Right.
sort of another route you can go down. There's other ways to put things into the public domain, by writing an article about it. Putting something into the public domain through a patent application is a nice route to go down because maybe you will get the patent granted. And then not only have you, prevented anyone else from saying it's their idea, but you also now have exclusivity over it because the patent office thought that, it met the hurdles for a patent.
Right.
Um, so those are sort of that's like number one and number two reasons to do it, to be able to talk about it and to be able to protect yourself. The last but not least reason, which I think should be the last consideration, is sort of getting exclusivity over it. Even though that's the purpose of the patent system, there's a lot of complications there with how do you know who's doing what and whether or not your organization, your legal team will want to go after a patent. So
Yeah. You,
that,
you don't strike me as the type of guy to want to go after all your competitors and start suing them willy nilly.
no, I mean
Yeah.
we don't do that. It's
Yeah.
not generally a good thing to do. It's not something that anyone in the data science field really does. So that's like last consideration, which is I think the opposite of when, most people think about patents. That would be number one on the list. Well, why would I patent something? I want to make sure no one else does it.
Yeah.
And for me, that's number three on the list. Number one is so that you can talk about it and feel safe talking about it. And number two is so that no one else says it's their idea when it
And then
was your
preventing
idea,
you from actually,
preventing you from actually
from
doing it.
actually doing it.
Yeah.
Those first two, like totally resonate with me, right? Like when I was first hearing you say, I want to be able to talk about it openly, I was like, well, why can't you just have them sign an NDA? But I imagine an NDA just means they don't, they aren't allowed to disclose it to others. But it doesn't mean that they can't necessarily go ahead and just turn around and file a patent. Well, maybe that would violate the NDA. I don't know. I'm not a lawyer, but it like the idea though that you're worried that your innovation from a process standpoint, that somebody else might sort of preempt you and file it, thus preventing you from rolling out this innovative process. Makes a lot of sense to me for sure. right?
Yeah.
Yeah.
And so that's for me is the major consideration.
Yeah.
Um, yep.
Well, cool. Is there any like I'm just the last thing I have on this topic that I'm curious about? Is there any sort of like lessons learned, like if you had to do it all over again, that you might tweak
On the patenting side or
on
on
the
the
patenting side?
team?
Yeah, I
Yeah, the
mean,
patenting
if I
side.
asked you about a more general question, we might be here for another
Yeah, oh
hour.
yeah. There's
Yeah,
also all sorts of stuff there. Yeah, I think on the it took me a long time to realize after having the team that this is something that we need to think about
yeah,
with everything that we do. Um, and now that it's on my mind, it's every time we generate original work, it's a conversation that we have, which is this an original idea or does this idea already exist out there in the world? And if it doesn't exist out there in the world, then we need to have a conversation. That's sort of number one. Number two is, going back to where we started, which is like the ethos of data science, is, talking to the people on your data science team about what this is really about and why we're thinking about patenting things to not leave like a sour taste in anyone's mouth about you know why the organization is looking at patenting their work. Most people think, oh yeah, it's cool, I get a patent, and then in the back of their head, it's kind of like, well, I use all these open source things, and Facebook has like profit, and now LinkedIn has their own time series, and all these big companies have open source projects, right, that they're rolling out into the world, and it seems against the ethos, and I think having the conversation with your team about what is this about? This is actually about public disclosure. This is actually about making sure other people don't say they had your idea and take it away from you, and now you can't, exercise
we
that
can't. Yeah, we
anymore.
can't. You do that.
Um,
Yeah,
so I think
totally.
those are the two main things, just, understanding that it's something that's out there and it's in the arsenal of copywriting and open sourcing and trade secret, just not automatically reverting to trade secret, that in many cases going the patent or at least patent application route is there, and making sure that the team understands like what this is about and why it's important for them and for the work that they do.
Yeah. Well, that's Kli. That was fascinating. I knew very little about the patent process. I think in my early years in my career, it was a point of pride to have X number of patents. Like, oh, so and so has 25 patents filed. You immediately just in my vision of that person is like they're this sort of mad scientist and they're this innovator.
Yeah.
And these days, like it's fairly rare, but it's good to understand why and when you should use it and how it can be applicable. And in this world of open source, like there is a place for this patent process, and I think you did a great job of summarizing when to think about it, how you should think about it. And I think many data science teams out there should be thinking about this as they do their work. Well,
Yeah,
this has been great.
totally agree.
Well, Kli, I really appreciated you taking the time. If people want to get in touch with you and learn, directly, can they reach, link up with you on LinkedIn and is that the
Yeah,
best way to get a
definitely.
hold of you?
So if anyone wants to get in touch, whether you're new to the field or in the field already, and you want to share ideas, best way to find me is on LinkedIn. Send me a direct message. Would love to talk to anyone listening who's interested.
Well, great. Well, thanks again, Kli, and have a great rest of your week.
Yep, you too, Dave. Thank you.